Hello, dear colleagues, professors, and chairpersons. Thank you very much for this opportunity. My name is ESKİZENGİN, and I'm a PhD candidate at Ankara University, Department of Biology. Today, I'm gonna present you the biosynthesis of cerium oxide nanoparticles using Persa americana extract and evaluation of their antioxidant activity. In our study, we described a facile and environmentally friendly strategy for the synthesis of cerium oxide nanoparticles using plant extract-based green synthesis. The reduction and formation of the nanoparticles was monitored through the FTIR spectroscopy, which was also carried out to identify the functional groups of biosynthesized cerium oxide nanoparticles. The size and zeta potential values indicated the biosynthesized nanoparticle stability and surface charge features. The morphology, the shape, and the size of the nanoparticles were analyzed in the transmission electron microscope and scanning electron microscope. The clustering nature of the nanoparticle was analyzed in an X-ray diffractometer. Additionally, the antioxidant activities of the nanoparticles were evaluated by the scavenging capability of DPPH-free radicals. In just a few decades, nanotechnology and nanoscience have become fundamentally important for industrial applications and medical devices such as diagnostic biosensors, drug delivery systems, and imaging probes. For example, in the food industry, nanomaterials are used to greatly increase the production, packaging, shelf life, and bioavailability of nutrients. Nanomaterials are also being used to create next-generation solar cells, hydrogen fuel cells, and new hydrogen storage systems that can provide clean energy. However, the most significant advances in nanotechnology offer a wide scope of research to the field of biomedicine and cancer therapeutics in particular, due to their great potential to provide innovative solutions, overcome the limitations arising from the traditional chemotherapy and radiotherapy approaches. In the United States, the National Nanotechnology Initiative has a budget of up to $2 billion to support nanoscience, engineering, and technology. But on the other hand, Turkish Republic of Ministry of Science, Industry and Technology reported that the cumulative number of publications in 2016 was 2,366. Although it cannot be fully revealed due to reasons such as number of researchers in this field in Turkey, faculty members working in many fields, and nanotechnology being an interdisciplinary field of study. It has been reported that it ranks 23rd in the country ranking. From this perspective, Turkey still appears as an area open to development and investment in terms of nanoscience and nanotechnology. Cerium oxide nanoparticles are used in various fields due to their unique surface chemistry, high stability, and biocompatibility. They regulate and scavenge harmful reactive oxygen species. Additionally, green synthesis, a safer and more scalable approach, is being explored for environmentally friendly one-step preparation of nano-sized materials. Biological agents like bacteria, fungi, yeasts, and plants can be used as bio-nanofactories for the one-step rapid synthesis of nanoparticles. Green methods offer less failure risk, low cost, and ease of characterization, but have limitations such as chemical reduction, microemulsion, electrochemical and thermal decomposition. The demand for reliable, non-toxic, high-yield, and eco-sustainable metallic nanoparticle synthesis techniques is growing, with biological synthesis methods being an attractive alternative. This study will assess the antioxidant potential of this chosen method compared to other synthesis methods in the literature. Okay, let's see the methods. Persa americana avocado was purchased from the local market. After washing the debris and dirt outside, its exocarp was peeled off and washed again in distillated water. Afterward, the peel was cut into thin strips. Then 10% of peel was extracted in distilled water and 60 centigrade degrees for 3 hours and filtered using Wattman paper. Subsequently, 3.16 gram ammonium cerium sulfate dehydrate was dissolved in 50 milliliters of distilled water. After 30 minutes, 2.5 milliliters of peel extract was added dropwise to the solution and stirred 50 degrees for 1 hour. The obtained nanoparticles were centrifuged at 900 RPMs for 10 minutes. The centrifugations of nanoparticles was carried out under the same conditions and washed with ethanol and distilled water, and finally dried at the 60 centigrade degrees for 12 hours and further calcinated at 600 degrees for 1 hour. The synthesized cerium oxide nanoparticles was characterized using particle size analyzer and zeta potential, transmission electron microscope, scanning electron microscope, XRD, and FTIR analysis. In brief, the size distributions of nanoparticles were analyzed using zetasizer instruments. The size and shape of nanoparticles were observed by transmission electron microscope and scanning electron microscope. The crystal structure and purity of the nanoparticles was determined using XRD. FTIR has been carried out due to conjugation of Persa americana with cerium oxide nanoparticles. DPPH free radical scavenging assay of nanoparticles was investigated. According to this protocol, 0.5 milliliter was continuously stirred with different concentrations of nanoparticles, as you can see in the slide. After kept in an incubator for 20 minutes, the absorbance was examined by the spectrophotometer at wavelength of 517 nanometers. In this experiment, vitamin C was applied as standard. So let's see our results. The FTIR spectroscopy analysis was performed to determine the role of Persa americana exocarp water extracts bioactive compounds in the synthesis of nanoparticles. The peaks could be due to the OH, aliphatic CH, and C double bond O stretching vibration of flavonoid and phenolic groups, which indicated the presence of aromatic groups along with the caped cerium oxide nanoparticles. The additional peaks are observed, and some of the peaks positions in biosynthesized nanoparticles are slightly shifted towards higher wave numbers when compared to that calcinated cerium oxide nanoparticles. The DLS measurements of cerium oxide nanoparticles also revealed an aggregation tendency with the hydrodynamic size of 1 mg per milliliter dispersion. Average size was evaluated as 522 nanometers. The zeta potential values of minus 32.5 millivolt clearly indicate that biosynthesized cerium oxide nanoparticles have good stability. The high negative values of zeta potential confirm that capping particles present on the surface of nanoparticles, they are mainly comprised with the negatively charged groups, which have moderate stability of nanoparticles. The proteins in the extract are responsible for reducing metal ions. They are efficient in stabilizing the synthesizing nanoparticles. The morphology of cerium oxide nanoparticles was characterized by TEM and SEM evaluations. TEM results revealed uniform and spherical shape of cerium oxide nanoparticles. TEM micrograph also demonstrated appropriate distribution of cerium oxide nanoparticles with around 30 nanometer diameter under ultrasonic agitation. This result correlated to the calculated crystallite size using the Debye-Scherrer formula. SEM results showed that the obtained spherical morphology in nanoscale range with agglomeration. In the X-ray diffraction patterns as shown in the figure, the peaks at 2 theta values are consistent with the literature. Furthermore, the crystallite size of cerium oxide nanoparticles was calculated 30 nanometer using the Debye-Scherrer formula based on the most profound peak corresponding to the 111 plane. DPPH is a dark-colored crystalline powder composed of stable free radical molecules which used as an antioxidant assay. The decrease in absorption is considered as a measure of the extent of radical scavenging. The radical scavenging activity values were expressed as the ratio, which was evaluated as of vitamin C, is 98.5% at 2.5 milligrams per milliliter and 42.1 for cerium oxide. But as you can see, cerium oxide nanoparticles did not show an obvious trend with the increased dosage. The radical scavenging activity was maximum 42.7% at 1.5 milligram per milliliter. We can say it's above 40%. In the biosynthesis of cerium oxide nanoparticles, FTIR analysis revealed that Persa americana extract acts as an effective capping agent, contributing to the stable formation of crystalline nanoparticles as confirmed by XRD data. The content of the biomass is correlated with the reduction in the particle size of nanoparticles, suggesting that the formation of biosynthesized cerium oxide nanoparticle complex may inhibit aggregation. However, the calcination process clearly demonstrated agglomeration, as observed in the both transmission electron microscopy and scanning electron microscopy analysis. The DPPH assay results demonstrated promising antioxidant activity, consistent with finding from other studies. For instance, Zirconium tin dual-doped cerium oxide nanoparticles synthesized using an aqueous leaf extract, Pometia pinnata, showed a reaction rate of 1.5 milligrams per milliliter with radical scavenging activity values ranging between 80% and 95% in 30 minutes. Cerium oxide nanoparticles synthesized using Origanum mahorana leaf extract demonstrated an radical scavenging activity value of 89.2% at 0.5 milligrams per milliliter. In another study, cerium oxide nanoparticles synthesized using Pelargonium hortorum showed an radical scavenging activity value of 69.8% in this study. These are the references, and thank you for your interest, and also a special thanks to my dear colleague Can Ergün. Thank you very much for your attention.